So this is going to play on something we have done before that I coin U-Substitution, because that's what we're going to call it when you guys get to calculus. U-Substitution always refers to a temporary substitution. It means we're going to go back to x's at some point. You guys did U-Substitution last semester when we did problems that were like this. 5 over x minus 2 over y equals 4. And 8 over 3x minus 12 over 5y is equal to 1. It wasn't u we used a's and b's. Did we use u's and b's? We used u's and b's. Okay, so we would say let u equal what? Oh, that would just be
1x.
1 over x. And we would let v equal 1 over y. So then I would rewrite this entire system as 5u minus 2v equals 4. Guys, please. And 8/3 u minus 12/5 v is equal to 1. And I would go from there. That is not the problem type we're doing today, but I wanted to remind you guys of where we've done this before. Additionally, you saw a problem in the homework we just went over that hinted to this. 7 over root x minus 1 plus 2 times root x minus 1 equals 4. And in this case, you can work this without u's. You don't have to do those, but it's a lot easier oftentimes if you just say, let u equal the thing that I want to temporarily replace. Let's work with that as 7 over u plus 2u equals 4, because this could be something that I actually could deal with. Multiply both sides by a u to get 7 plus 2u squared equals 4u, or 2u squared minus 4u plus 7 equals 0. And then I could go forward with that using the quadratic formula or complete the square. And I'm going to leave this as a little ... because this is also not the problem I want to do right now. I want to show you where you can use U-substitutions. The goal of today is to decide, what do I replace with u? That way, if I replace the right thing, I get something that looks like au squared plus bu plus c equals 0, something you know how to work with. So let's start with a simple example. 1 over y squared minus 9 over y plus 8 equals 0. Pause for a second. And resume. What would you let u be equal to?
1 over y squared.
I would not do 1 over y squared. You want u to be something that you're not only replacing u, you're then also replacing u squared. So if u is 1 over y, then u squared is 1 over y squared. So in this problem, we look at this piece right here, which is now becoming the u squared, minus, remember this is 9 times 1 over y, so that becomes 9u plus 8 equals 0. You can complete the square, you can use quadratic formula, or if you're really smart, you can
Factor.
u minus 8 times u plus minus 1 is equal to 0, which means that u is equal to 8 or u is equal to 1. Now we go back. U was actually 1 over y, so 1 over y is equal to 8 or 1 over y is equal to 1, which means that y is 1/8 or y is 1. We're not dividing by 0 with any of those numbers, and we're not taking the square roots of negative numbers with any of those numbers. We're not squaring both sides. Those are both okay. Yes? I just said we don't need to. We're not dividing by 0. We're not taking the square roots of negative numbers, and at no point did I square both sides. Yes?
Yeah, you put negative on that side, but not.
Oopsie.
Exactly. That's what I was thinking.
Exactly.
Okay, number 2. 5x plus 1 squared plus 6 equals 7 times 5x plus 1. Sometimes these U-substitutions are more optional, but I still think they make the problem easier when you spot it. You're less likely to make a mistake. So if I were to ask you to do a substitution on this one, what would you let U be equal to?
5x plus 1.
So we get U squared plus 6 equals 7U. Or U squared minus 7U plus 6 is equal to 0. This also factors. U minus 6, U minus 1. Which means that U could be equal to 6 or U could be equal to 1. But it wasn't U. It was 5x plus 1 equals 6, or, I'm going to write this underneath, 5x plus 1 equals 6, or 5x plus 1 equals 1. Which means that x is equal to 1 or x is equal to 0. Just do a check really quick. Are you ever dividing by 0?
You don't want to be.
No. Are you ever taking the square root of a negative number? These are both acceptable. Yes?
Never mind. Same thing.
Okay. Yes?
Yeah, never mind. I don't care. That's a bad attitude.
1 over 9x squared minus 7 over 3x plus 6 is equal to 0. You have two options on a problem like this. You could multiply both sides by an x squared. That's okay. You're going to have to check your answers. I want to do this with the substitution, one that we've kind of done before. We're going to let U equal. I'm going to make this a little bit simpler. Instead of letting U equal 1 over x, I'm going to let U be 1 over 3x, because then U squared is 1 over 9x squared. You want to do the most consistently large thing possible so that you make this problem easier. You get U squared minus 7U plus 6 equals 0. Look at the problem right above it. It's this exact same U factoring. You're going to have problems on this homework that actually go through the same factoring, but it's a different U. It's a different thing that you're substituting. U minus 6, U minus 1. You get U equals 6 or U equals 1. But then you have to go back and substitute 1 over 3x is equal to 6, or 1 over 3x is equal to 1. If I multiply both sides of each of these by 3x, I get 1 is equal to 18x, or 1 is equal to 3x, which means x is equal to 1/18th, or x is equal to 1/3. And both of those are fine because you're not taking the square root of a negative number, and you're not dividing by 0. So I want to give you a way to do a type of problem that we have done before. We're going to call this 4a, because I'm going to do the same problem in two different ways. You also are going to have directions that ask you to do this. 6x minus 13 root x equals negative 5. One of the ways you've done is to isolate the radical and square both sides. But you can also say, let u equal root x, which means that u squared is what? So this becomes 6u squared minus 13u equals negative 5, or 6u squared minus 13u plus 5 is equal to 0. Before you start using quadratic formula, see if it can factor. 3 times 5 is 15, minus the other 2 would be 13. So if I make it so that I'm multiplying 3 and 5 together, I should get minus 15 plus 2.
But no.
That makes negative
But no,
17.
no.
Nope. That's
Yeah,
ridiculous.
that's
Ha.
positive 5.
Aha! I made one.
You see
proved
it, Mr.
I
one
do.
thing of your argument wrong, so everything you've ever said is wrong.
I do see it.
I don't see it.
So then maybe if I switch, maybe
That's
I don't
ridiculous.
see it.
I see it.
That's
I see it.
ridiculous.
Oh, no, you can do the
It's
switch
over.
it. So 2u times
I
5.
quit.
Yeah, so there you go.
so minus 10
Minus
minus 3,
Because you were wrong on
Aha.
saying all of
That
the
is
statements are
wrong.
false.
and we get u is equal to 5/3. U is equal to 1/2. We switched the factoring around and made it work.
Yeah.
While you were standing up and not looking, we just did that. So I get root x is equal to 5/3, or root x is equal to 1/2, which means that x is equal to 25/9, or x is equal to 1/4. Did I at any point square both sides?
Yes.
Well, at the end,
I did. That counts. We need to check both. So I need to go and to actually plug these back into the original problem. 6 times 25/9 minus 13 times the square root of 25/9, 5/3. Does that equal negative 5? Cancel these out. We get 50/3 minus 65/3, or negative 15/3. Yes, that does equal negative 5.
Let's go.
25/9 works. Now you have to check 6/4. 6 times 1/4
Is that only
minus 13 times the square root of 1/4 is 13/2. This gives me 3/2 minus 13/2, or negative 10/2. That also equals negative 5. Don't automatically assume that things will work or not work depending on if they're positive or negative. Both of these are actually acceptable solutions, but you have to establish that by checking both answers. I told you guys that we were going to do the same problem in 2 different ways. This is good to review the other way that you had to do this problem, given that the last test was most of your guys' favorite test we've done so far.
I mean, I got a 90.
Okay, so
I got C minus. Yeah.
let's work on this one. We get the root x by itself, so I'm going to go 6x plus 5 is equal to 13 root x. Then I square both sides. 36x squared plus 60x plus 25.
Wait.
FOIL. Please tell me you didn't. When you square the left...
Sorry, I was looking at the... I was just doing the 100.
Okay, yeah.
Don't worry.
169x. So you get 36x squared minus 109x plus 25 is equal to 0. That would not be fun to factor, would it?
Let's divide.
I like it.
No, we can't.
You can't.
Quadratic.
If only you knew what the answers actually were, so you could actually cheat with what the factors would have to be. Like, what would be the one that would give you 25/9? Wouldn't that be 9x minus 25? That'd be the one that would give you the 25/9. And then the one that would give you the 1/4 would be 4x minus 1. And then you can first, outer, inner, last and check that. That actually gets you. Which one of the two of these methods would have actually been easier, the first one or the second? The first one. It led to a better factoring. This one, you could still factor. What do you do if you can't factor that, but you know it factors? Quadratic formula or complete the square. Just recognizing that to get the quadratic formula or complete the square on that, you would have to divide both sides by 36 to complete the square. And you're going to do half of 109 36 squared. It's not going to be fun, but you can do it.
And that's why I quit math and dropped out of school.
Okay, we are done.